All right, this is section 4.4, quadratic relations in factored form. So as I said on the board, we've covered standard form here. What's the big value of standard form? A, right, yeah. A tells us a whole bunch of things, right? This A value. And vertex form we covered yesterday. We get the value of A, but we also get the vertex, which is what? H. Okay, good. A value, and then the vertex we get HK. Now in factored form, this is what we're going to be learning out today. We get the new formula here, y equals A, x minus r, and x minus x, where A is not equal to 0. Okay. Let me ask a general question now. So now you have learned three different formulas. For what? What are those three formulas telling you? What is it? What is it for? Alan? Yes, it's for parabola. So in grade 9, we learned one formula, y equals mx plus b, which was very important, and it told us about the behavior of a straight line. Okay? Now we are learning these three formulas to tell us the behavior of a parabola. That's the idea. So this told us about this graph. These three tell us about this graph. Why not just one formula? Like y equals mx plus b. Why do I just not teach you y equals ax squared plus bx plus c? Why am I teaching you three different versions? Anybody have any idea? Yeah, Max.
They all show us different things.
Yeah, they all show us different things about the graph. Okay? The first standard form will show us the shape of the parabola and the direction that it opens. Okay? The second one will show us the vertex here. And finally, the third formula will show us these 2 points, which are considered the zeros. Or when when y is equal to 0, they're called the zeros. Okay? So they all tell us different things. So here's our first example. It says create a table of values for the relation 2x minus 5, x plus 3. Alright, so our first thing it asks us to do is to create this big table of values. So how am I going to do that? Who can tell me? Douglas, what am I going to do to find out all these y values? Here's the formula. What am I going to do?
You can start off with 2 at 0.
2 at 0. What do you mean?
Yeah, on the table.
Here? 0?
Yeah.
You want to start here? Okay. So you're putting in, what are you doing with the 0?
I don't know.
You're not sure? Guys, how do we fill out a table of values? Andrew?
You have to plug in minus 6 to x.
Yeah, that's it. I have to plug in these values into the formula, right? You don't remember this, Douglas? Right? And that will give us the y values. So let's just do one of them here. So y equals 2, and then we have negative 6, that's my x value, minus 5, negative 6 plus 3. Okay, I've substituted in negative 6 for x. So now I get 2 minus 11, because negative 6 minus 5 is negative 11. And then minus 6 plus 3 is minus 3. Now I have 2 times negative 11 is negative 22, times negative 3 is equal to positive 66. Okay, so here I would write 66. Okay, you're going to do the same thing with negative 5. You're going to substitute it in here, and you're going to get these values. This would have taken, how long? Janier, how long would have this taken you?
Probably like 2 minutes.
2 minutes? This would have taken me like 3 hours. It's a lot of work, right? You're plugging in, plugging in, plugging in, plugging in. Would have taken a long time.
Also, you can see there's like a pattern.
There's not a pattern yet. You're going to see a pattern when we get to second differences. First differences, how do we find out first differences, Jaden? What's this value here going to be?
Minus 5 and 6.
Sorry? No, not these values. You minus the y values.
Yeah, the 40 with the 6
Yeah, so what would it be? What's 40 minus 66?
26.
Yeah, but not positive, negative. Okay? 18 minus 40 is negative 22. 0 minus 18 is negative 18. Negative 14 minus 0 is just negative 14. Negative 24 minus minus 14, so it's plus 14. So it would be negative 10, right? Negative 30 minus minus 24, so you're adding 24 to negative 30, so that's negative 6. Okay, negative 32, this is negative 2. Negative 32 plus 32 is positive 30, is positive 2. This would be positive 6, 10, 14, and 18. Okay? And now I'm going to subtract these two to get my second differences. So negative 22 plus 26, because it's minus minus 26, so it's going to be 4. 18, negative 18 plus 22, negative 22 is 4. 4, 4, 4, 4, 4, 4, 4, 4. Okay, we did our table of values. Use finite differences to determine the type of relation. So what type of relation is this if all the second differences are the same? Rudy? Quadratic, yeah. So therefore, this is a quadratic equation. All right, now we're gonna prove that because we have our x and y points over here, and we can point them out, right? So the first one is negative 666. So I'm gonna go x negative 6. It's actually way off the graph, so I can't even graph that one. It's like negative 6 is way over here, and then 66 is way up here. So let's try a different strategy. Let's start at negative 3. So we're gonna go to negative 3, 0. That's easy. Negative 3, 0. Here's my point, negative 3, 0. Okay. We know at 5 it's 0 from down here. 5, 0. So we'll go over to 5 and we'll put 0 there. Okay. And then we can get the vertex we know is the exact middle. So negative 3 to 5 is 8. So we're going to go 4 down from 5 is 1. So this is going to be the vertex when x is 1. So let's check that out. X is 1. That's our lowest point. Negative 32. So we're going to come all the way down to here. Okay, and you can plot as many of these as you like. Let's do one more. Somewhere around x is 3, negative 24. So x is 3. We're gonna go negative 24. Okay, and then we'll do x is negative 2 maybe? Is negative, well, let's do the same one. X is negative 1, so we're going to get negative 24. Same thing. Okay, that's enough for me. I'm going to draw it. Any questions on how I graph this parabola? Good. Everyone's with me? Pretty straightforward. We created a table of values, we plotted our points, and we traced it in. Now, the beauty of, let's see if we get there. Well, let's just keep going. We'll keep going. The beauty of standard form, right? Like right away, I could have seen from this formula that my x-intercepts, or sorry, my x-intercepts are 5 and 3. So I would have just done 5 and 3. And then I could have just substituted in the axis of symmetry, which I know by adding 5 and -3, if I add those up, I get 5 minus 3 is 2. So I would get 2 divided by 2 is 1. So I know my axis of symmetry is 1. So right away, I could get my x value of the vertex. That's my axis of symmetry, x equals 1. I would sub that in to this formula, and I would get my y value for the vertex. And I would find my vertex to be 1, -32. And so within one simple substitution, I would have the vertex, I would have my zeros, and I'd have my graph. That's the power of standard form. All right. So it says, identify the x-intercepts and zeros/zeros from the graph. So remember, I said they're called the same thing. X-intercepts is when they cross the x-axis, and zeros when the y value is 0. So what are they here? Yeah, Josiah? 3 and 0. No. The zeros are here and here, right? So -3, you're right, and 5, right? So the x or zeros for the graph would be -3, 0, and 5, 0. Those are the 2 points, right? Or you could just even say x is equal to -3 and 5. Identify the coordinates of the vertex using the coordinates of the x-intercepts. So the x-intercepts, so this is exactly what I was talking about. So the first thing you would do is find the axis of symmetry. So you would take -3, you would add it to 5, and divide it by 2. Okay, this is r plus s divided by 2. So we get 2 divided by 2 is equal to 1. So our axis of symmetry is x equals 1. And then we sub into the formula to find y. So y is equal to -24. Okay? Sorry, -32. We're substituting in here. For x, we're substituting in 1. Right? So I have 1 minus 5 is -4 times 4. So we have 16 here. -16 times 2 is -32. Finally, it says, summarize your findings, describe how to determine the x-intercepts and vertex of this. Okay? Well, the x of the vertex, right, that's the axis of symmetry. So this is just x plus s over 2. And then we sub this back to find y. That gives us our vertex. Describe how to determine the x-intercepts. So the x-intercepts are just r and s. These are the x-intercepts. Conclusion. X-intercepts. X is equal to r and x is equal to s are the x-intercepts, just like up here. To find the vertex, I add up the zeros, r and s, and divide by 2. This is the x-coordinate of the vertex. Substitute the x-coordinate of the vertex to solve for y. This is the y coordinate of the vertex. The quadratic relation in factored form can have 1, 0, or 2 zeros. So here is an example of 1, 1, 0. This one is 2 zeros. And I don't see it here, but this would be zero zeros. It does not cross the x-axis. Okay, now it's important. So for these ones, which is either this or this, thank you. These two parabolas, no zeros. Okay, if they don't have any zeros, somebody asked this question, what happens then? Therefore, all right, parabolas that do not have x-intercepts cannot be written in factored form. Okay, so you will never get a parabola in factored form. Remember, factored form looks like this. You'll never get something written like this that looks like this. You cannot. Any questions? We will look at the formula for those eventually. Okay. Next, determine zeros, axis of symmetry, vertex, and y-intercept of the quadratic relation 2x, x plus 6. All right, I need some help with this one. Alan, what are the zeros here? We know the zeros are, so they're when y equals 0, right? X is equal to what, and x is equal to what? What are my zeros for this formula? Alan. Okay, so you want to rewrite this like this. Okay, then what?
Then 0, 0 and 6 into...
Well, let's just finish writing this out, okay? We know y is equal to a x minus r, x minus s, okay? So you've done the correct thing with r. You've just said minus 0 because there's nothing there. How can I show this plus 6 as negative s? How would I show it? Yeah, x. Yeah. No. Not minus 6, but minus.
-6.
Yeah. Okay. You've done a lot of work here. So what are the zeros?
0 and -6.
Very good. Okay. My hope is that most of you could see that these are the zeros just by looking at this. Does that make sense? You guys can see that? Anybody not see that? Have to go through this step? You don't see it, Stefan? Okay. If I have just x by itself, well, it's subtracting nothing, right? So then I know that the x value has to be 0. The r value, sorry, that it's subtracting is 0. There's just an x by itself, it has to be a 0. If this is plus 6, well, I know the formula says minus a number, but because it says positive, I know that that number has to be negative. So it's minus 6. Make sense? Maxim?
So anything negative is also classified as a 0?
Yes. What? Yeah. So if this was negative 6, I would just put x equals positive 6. Okay? Remember your zeros are R and S. Axis of symmetry then, Adrian, x equals?
X equals -3.
Okay, what's the formula? You're right, but
R plus S.
yes, R plus S divided by 2. What's R?
R is, we'll just use 6,
It would be the first one, so what's R?
0,
Yeah, 0 plus?
-6.
Yes. Good. Over 2, so we get -3. So that is our axis of symmetry. Okay? Vertex now. Jadane, you know what to do? What do you do? I'm going to rewrite the equation up here for us. As a bit of a hint, right? Our axis of symmetry is this. So what do I do? Yeah, so you're what are you doing? Tell me what you're doing. Yeah, you're subbing in the -3 for x. Very good. Okay, so we have y equals 2 and then -3 here. And then I have -3 plus 6. So now I've substituted x because remember the axis of symmetry, x is it's the x value of the vertex. So I need to find the y value of the vertex now, so I sub it in, okay? So what is 2 times -3? -6, good. And then -3 plus 6? 3. Okay, I get -18. Therefore, my vertex is what? RC. Come on, bro. You got this. You're not paying attention. Teodi. What's the vertex, Teodi? This is the x coordinate of the vertex. This is the y coordinate of the vertex. What's the vertex?
-3, -8.
Yeah, you guys, come on, guys. Can't teach if you're not listening. You're not paying attention. Let's go. The y-intercept now. What is the y-intercept? Let's think about it. So we've been drawing all these vertexes, right? We've been drawing this vertex, that vertex. We know the zeros when it hits the x-axis, right? Now we're asking about the y-intercept, okay? There's only one, right? There's only one y-intercept ever on parabolas that are running vertically. We don't deal with parabolas running horizontally, so there's only ever one y. How can we find the y-intercept, Adrian?
I don't know how to find it, but I know it's 0.
Okay. Why? How do you know it's 0?
I drew it onto the graph.
Oh, you drew the graph. Okay. So how do we find the y-intercept? What's the x value when y is 0? What's the x value? Okay, here's a graph. Here's our y-intercept. What's the x value here? What? Not 1. Come on, guys. What's the x value here? What's the x value here? Okay. What is the x value whenever you have a y-intercept? 0. We know this from straight lines, right? Y equals mx plus b. You substitute in 0 for the x value to find the y-intercept. Okay, so we know our x value is equal to 0. We know our formula is this. So what's the y-intercept? We need to sub in x equals 0 for x. So we're going to get 2 times 0, and 0 plus 6, we get 0. Okay? 2 times 0 is 0. 0 times 6 is 0. So we get y equals 0. Okay? So we know if the y-intercept is 0 when x is 0, we know this parabola is going to pass through the origin, 0, 0. Okay? Oh, what's the step pattern? Remember our standard step pattern is 1, 3, 5. This is going to be a times 1, 3, 5. What's a here? 2. Yep. 2 times 1, 3, 5. So we get 2, 6, 10. All right. We are loaded with information here, so we should be able to graph this. I'm going to do it as fast as I would do it normally. This is how I would choose to graph it. There's a few ways because we have the zeros. Well, let's because we're working in factored form, let's work with the zeros. I would have just done vertex and step pattern, but let's work with the zeros and then we can confirm the step pattern. So the zeros we have are 0 and -6. We know that's where it crosses the x-axis, so I'm going to put a big dot on 0 and a big dot on -6. All right? So there are the 2 points that it crosses. Next, I know the vertex is -3 and -18. So I'll go to -3 and I'll go down to -18. Okay, so already with those 3 points, I can pretty much graph here. Let's just confirm with the step pattern. So the step pattern we know is 2, 6, 10. So I'll start at the vertex. We know it's positive, so we know we're going up. So these are in ones, so that's good. I can go over 1 square. So I'm going to go over 1 square, and I'm going to go up how many? Rudy? 2. Okay, I'm going to go over 1. I'm going to go up how many, Douglas?
6.
1, 2, 3, 4, 5, 6. I'm going to go over 1. I'm going to go up how many, Josiah?
Oh, that's right.
10. Good. And I'm at -10, so I'm going to hit 0. Boom. And then I'm just going to mirror this. Okay, so there is our drawing. Ooh. Try that part again. Okay? Much easier than table of values, right? I hope. Yes? No? Maybe so? Sort of? You weren't listening then, RC. If it was only sort of easier than table of values, you're not listening, man. Come on. Should have been way easier. Determine the zeros, axis of symmetry, vertex, and y-intercept of the quadratic relation. This. RC, you're going to help me on this one now. I think I've been missing you. You're behind me now. You're hiding. What's the zeros here? Okay, I'm going to help you out here because this does look a little weird. How could I rewrite this in factored form? Anybody know? Sorry, Andrew, you want to try?
X plus 0 bracket x minus 0.
Nope. I don't know where you're getting all these zeros. Jeff.
I don't know if this is right, but it would be bracket x minus 2 times bracket x minus 2.
Yep. That's exactly right. Because when we square a number, we're multiplying itself, right? By itself, okay? So now that I have this, RC, you're going to help me out here. What are the zeros? It's set up perfectly for you to find the zeros. There are an S. So what are the zeros? X equals? Come on. RC. Who knows what the zeros are here? Put your hands up. No, Milkius? Come on, man. I'm not doing a good job if you don't know what the zeros are. Josiah, you know what the zeros are? Oh, you're going to have to fire me, guys. What are the zeros? They're right here. They're R and S. R and S. What are they? Please, up here, Josiah, what are they? Milkius, what are they? Yeah, just 2 and 2.
Oh, I didn't see the top part. My fault.
Come on, guys. In this case, is there 2 x-intercepts or 1 x-intercept? Who said 2? There's only 1, right? It's x equals 2. So my zeros are just x equals 2, right? Or if you want to think of it in a point form, it's 2, 0. My axis of symmetry then is, Douglas? Yes. Thank you. My vertex then is, I'll help you out. I'm going to write it in here. I'm going to write the short formula. What do I do for axis of symmetry? Or sorry, for vertex, yeah.
You plug in the 2 into the x.
Yep.
So 2 minus 2
Yep.
0. E equals 0.
Yep. So y is 0 and x is 2. So our vertex then is 2, 0. I hope already you guys can visualize this parabola. So only got 1 point on the x-axis. My y-intercept. The last thing I need to figure out. So y-intercept happens when x is equal to 0. That's when it happens. Okay, so if I have my equation, what do? Teodi. How do I find out my y-intercept? Yeah, so what's x?
0.
Right, so I get what's negative 2 squared, Teodi? Yeah. So my y-intercept is 4. All right. Last thing, step pattern. Josiah, what's the step pattern?
The 1, 2, 5.
Yeah. That's it, 1, 3, 5, because A is 1, right? A over here, you don't see it because it's 1. All right, so here we have all of this information. Liam, tell me how to graph it. You can do any way you want. You tell me where to
On the zeros, go 2.
Sorry?
On the x, the 2.
Okay, right here? Right here, right?
Yeah.
Yep. Then what?
And then you could go the step pattern.
Okay, step pattern. I'm gonna go 1, 3, 5. So 1 over, 1 up, 1 over, 3 up, 1 over,